Hello, this is Team ICA of UC Davis, Winter 2012 of Engineering 6, Andre Knossen. I'm Corey Hobbs.
I'm Eric Schmidt.
I'm Anthony Rascon.
And we're here today to talk about the Sudoku Generator and Solver. It's an interactive game where the user can either choose Novice or Pro. They can check the board to see if their inputs are correct. They can reset the board if they happen to stumble. And they can solve the puzzle by pressing the Solve button.
Now, to give a little demonstration of our Sudoku puzzle, we'll first start with the Novice button, which is the easy stage, which requires 30 missing spaces. Next, we have Pro, which has 50 missing spaces, and this is the hard one. If we press this button and try to figure out this puzzle, say 9, and press check, we'll obviously get an incorrect puzzle because we already have a 9. So now if we get rid of the 9 and put a 0 and check again, I'll say good. Now, since I don't think I can solve this puzzle, I'll press solve in order to get the results. And there you have it. And now the reset puzzle function can make you reset the whole puzzle to play another game. And there it is.
Okay, so now we'll talk about the code behind the GUI. First, with Sudoku generating function. And so this took quite a while. We tried to figure out how to generate a Sudoku. We ended up implementing a recursive function to generate it. And a recursive function works by first putting a random number in the first index of our zeros matrix, a 9 by 9, and then checking to see if that's valid. And it goes to the next index if it works, and if it doesn't work, it goes backwards. And then the way it checks to see if this, if whatever number we just put in there works, then we use the board valid function, and basically this just takes any sort of input, any sort of partially filled Sudoku input in, and first checks to see if all this rows have unique numbers in them, and all the columns have unique numbers in them, and all the subgrids have unique numbers in them. So then
And now we're going to talk about the implementation of the GUI and how it was programmed, a little bit of its structure. So let me pull that up real quick. So yeah, if we go here, when the GUI was made, we realized that the easiest way after other failed attempts was to create 81 individual text boxes. So these, yeah, it's actually 81 separate boxes, guys. Yeah, there's no easy way around it, not making one big box and filling it up. And we linked the indices of the array that we generated, so the Sudoku puzzle that's generated, to the exact edit box. So if this was edit 1, edit 2, edit 3, and so forth, it would be Sudoku index 1, 2, 3, and so forth. And then once you generate it, you just fill up the boxes and then change some of the properties so the user can change the number. And that's pretty much it. And then we added some cool little buttons over here: Novice, Pro, Solve, Check, and Reset. The little copyright down here, it's not real, but you know, don't steal our code. A little output box for the checker, and an instructions manual real quick. You know, got the team name up there. And that's pretty much for the GUI. It's simple. That was the easiest part of the whole program. And now we're going to give you 3 little things to watch out for when you're trying to do this project at home, in school, or whatever you're doing it for. First thing, when you try to implement a global variable, yeah, you might want to read up on that, because that was our biggest issue for this program. We were trying to link 2 functions together, and it was a little messy. So read up in your global variables.
And also, be sure not to use the brute force method, because it didn't work out for us.
Yeah, so after trying the brute force method, we discovered that using a recursive method to generate the Sudoku was pretty much the only way to go. Recursive allows you to change previous inputs, which allows you to move forward and actually complete a 9x9 Sudoku grid.
So other than that, I mean, there's other ways to do this, so don't feel like this is the end-all be-all of coding in MATLAB for Sudoku. It's just the easiest way that we found it to work most efficiently. So, with that said, this is Team ICA of UC Davis, Winter 2012. Have a great day.